We are going to start with the normal distribution. Towards the exam, people tend to also start even forgetting the few things they knew because of pressure. Please don't panic. Don't panic. Stay calm, stay confident. Believe that what you know, you will recall them. The more you panic, the more you forget even the simple things. Please don't panic. Don't panic. Okay, so let's start with the normal distribution. Let's start with normal distribution. Let's start with normal. Let's start with normal distribution. Now, with normal distribution, this one, normal distribution is a continuous probability. Is a continuous probability distribution. That follows a bear-shaped curve. Okay, that is our normal distribution. It's a continuous probability distribution that follows a bear-shaped curve, and it is symmetrical around the mean. It is symmetrical around the mean. They can ask you to define these things, 2 marks, 3 marks, around the mean. Okay, so that is it is symmetric around the mean, meaning that most data points are concentrated around the center. So that is your normal distribution probability. That is your normal distribution probability. But we need to also know the key properties of this. If they ask you to give some characteristics or some features or some properties of this normal distribution, can you list them? Okay, number one is that the mean that is new, okay, this mean we are talking about here is new. The median and the mode are the same when we are talking about normal distribution concept. The mean, median, and the mode are the same. That is property number one. Easy to recall for your exam purpose. The total area under this bell-shaped curve. The total area under this bell-shaped curve, under the curve, is 1 or 100%, which is 1. That is also another characteristic. Then next is that the probability of values occurring farther from the mean decreases. Okay, the more you keep on moving far away from the mean, the probabilities keep on decreasing. The probabilities keep on decreasing. Okay, the probability of values occurring farther from the mean, it keeps on decreasing. Okay, that is also another thing to note. That is another thing to note. Then maybe the last one we can say that it is defined by mean. It is defined by mean and the standard deviation and the standard deviation. That is also something that you need to know. That is also something that you need to know. As we see the formula, we are going to see that the formula has the mean and the standard deviation. Okay, has the mean and the standard deviation. Okay, that's what you can put. That's what you can put. If they ask you some of there are others, but let me pause here. How are you going to approach the calculation questions around this area? Take note. Take note. Also, maybe you can add here that for us to use the normal distribution probability, another feature you can put is that the NP and NQ, the NP and NQ, the NP and NQ, NP and NQ must be greater than 5 for you to use normal distribution, for you to know that you're dealing with a normal distribution probability. Your NP and NQ, P is the probability of success, Q is the probability of failure. Your NP and NQ must be greater than 5. If I get N times P, or if I get N times Q, or must be what greater than 5. If I find that one of them is not above 5, then I cannot use normal distribution probability. I have to bring the concept of binomial distribution. So please, this one is very, very key as you tackle some of the questions, the calculation numbers. That point is very, 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 very key. That point is very, very key. That point is very, very key. Now, I want to discuss some of the, of course, as we deal with the question, you will always know that this Z, okay, you can also say that the new this mean follows okay, we can say that X, the random variable X follows what we call the normal distribution into our mean, then followed by the variance, variances. The variance is sigma squared. Variance is sigma squared. Then next, we have another formula. As we determine Z, we always need to standardize. We always standardize. We always standardize X to be in the form of Z, where Z will be equal to where Z will always be equal to your z will always be equal to the x, this x, not your real x. This x minus, okay? Are we on? Are we on?
Yes,
Have you
admin, we are
noted this?
on.
Have you noted this?
Yes.
Please take note that when we are dealing with a variable, of course, we will be dealing with a variable x, a variable x, a random variable x. But as we get the probability, because we need to use the z table, we will always standardize. From the random variable x to z, okay? And as you standardize your value of z, your value of x, this is the formula that we are going to be using. Okay, so where you have x as, let's say, 18, where you have x as, let's say, 50, you will always try and make sure that you standardize that figure to be in the form of z, where it is 50. Now, if you standardize 50, what can you get? You'll be following this formula. The x you want to standardize, that is, let's say, 50 minus the mean over the standard deviation. That's how you will be standardizing. Okay, I believe these are good points to recall, and nothing like hard here. There is nothing like hard here. These ones are not hard. Okay, now going to the computations, how can we apply our knowledge, or how can we apply the normal distribution probability to answer our questions? We are going to start with this question. That is November. We are going to start with this question, November 2018. November 2018 question. That is quantitative techniques. Okay. And you have good marks. You have good marks here. A very good marks on part A. You have like 9 clean marks. These are really very, very clean. These are very, very clean. You can score these. You can score these marks within a few minutes. Okay, what are we told? We are told to determine the probability that its life is greater than its value is greater than 18 years. Its life. What is the life we are talking about here? We are told that any, I think it should be M. MER deals in solar products. A routine visit by Uganda National Bureau of Standards, UNBS, established that the life of the solar panels, MER sold was normally distributed. When you see this word, normally distributed, it is one of the probability that we have indicated here. Your x, not like the x's you have. Your x here, the random variable. We have said that the random variable here, your x is normally distributed. Here, when we say x, then we put that sign, means normally distributed. Okay, is normally distributed. What is our x here? Our x can be defined as the life of the solar panels. The life of the solar panels sold by MER. the life of the solar panels, followed by what? Followed by the life of the solar panels, followed by MEL. So it is normally distributed with mean years and standard deviation of 4 years. So you have mean, you also have the standard deviation. A quality controller from UNBS later visited the MEL and tested a sample of solar panels and picked one at a random. So how are you going to approach this? I am going to say from my concept, I am going to first say this is November 2018. Now November 2018. Question what? This is question 2. This is question 2. So we are going to start with part A. We are going to start with part A. And part A, for me to answer, I need the rate X. Let X be the life of the solar panel. Solar panels are sorted by maybe since examiner used the NEL, we can also use the NEL, but technically it should have been MEL. Okay, so that is our X. We have defined a variable. Then from one of the properties, we are seeing that your random variable, that is X, will always be normally distributed. It is normally distributed. What is our mean? Mu is our mean. What is our mean from the question? The mean from the question is what? Isn't it 25? And you have the standard deviation as 4. So that is sigma. So you have the mean as 25. Here you put 25. Then sigma alone is the standard deviation, which is what? 4. But if you square it, you get the variance. The rule is that one of the properties is that our random variable X follows mean and variance. So if you're given the standard deviation, you can square it. Okay. So, and sometimes examiner will give you only this. It's you to know that if I'm given this in a question, it means that this 25 is my mean. Then this 4 is my standard deviation. Because sometimes the examiner may not give you all those words. He can simplify the life by putting only this. Okay, so that is our concept, which I wanted you master right away from the start. That next time you may find that the question is not like this. You may find that the question is not like this. Okay, like the one given in the number. But you may find that it is given in this form. If it is given in this form, mean is 25. Standard deviation is 4, variance is 4 squared. Okay, so what do we need? We need the probability of X. The probability of X is what? The probability of X is what, guys? The probability of X is what? Who can tell me? The probability that its life is greater than what? Is greater than 18. Which sign can I use? Is greater than 18. This is the probability that we need. Okay? All right, all right, all right. So how can we get this? How can we get this? I like these numbers in a way that they don't take a lot of time. My humble request, don't hate these topics. Don't hate don't hate these topics. So when you are dealing with this, it will be probability of x is equal to, is greater or equal to probability of x is greater than 18. It will be, guys, you cannot solve this minus standardizing. You cannot solve this minus standardizing. That's why I had to bring this one, that we always standardize x to be in form of z. So where you have x, I am going to put z. I am going to put z. Z is greater than, now I standardize this figure. I standardize this figure. And when you're standardizing this figure, you will be telling your examiner that from Z is equal to this. From Z is equal to this. So it means that since from our Z is equal to this, where you have, okay, where you have 18. Okay, for you don't, you will be saying don't put these guys. For you, as you answer, you'll be saying that from z is equal to, after putting that first part, you'll say from z is equal to from z is equal to, then probability of x is greater than 18 will be standardized it where you have x, put z, then where you have 18, that is the value of x, so I put 18 here. But because I want standardize, I remove mean. I remove mean, which is 25. I remove mean, which is 25. Then what is my standard deviation? It is 4. In that way, you will have standardized your x. So what do you get on your calculator here? What do you get? Round off to, don't give yourself a lot of burden. Round off to only 2 decimal points. Round off to only 2 decimal points. So probability of z, is greater than what? Tell me. Negative. Get open bracket 18 minus 25, close bracket, divided by 4. What do you get? Negative what? Put some speed, guys. Put some speed.
Negative 1.75.
1.75. So that is your, that's the value after standardizing. The moment you have this, then what you're going to do is to recall that we are dealing with a bell-shaped T. We are dealing with a bell-shaped curve. You shade the wanted region. Where do you want? Yeah? The wanted region is where? For this one, don't shade the unwanted region. Where do you, if they say probability of Z is greater than negative 1.7, where is your wanted region? Do you shade this side or you shade the right side? Do you shade the left side or right side? Who can tell me? Where do you find values greater than negative 1.75? You shade the wanted region. You shade the right side because it's where you find values that are greater than negative 1.17. So I shade the right what? I shade the right side. Please take note. You shade where you want. For this one, it is not like linear programming that you're going to shade the unwanted region. Shade where you are interested in. Okay, and don't put a lot of design to scare your neighbor that for you have content. Don't put a lot of what? A lot of design. Here they will not mark your designs. They mark the concept. Okay, so here we are. I have shaded the right side. Okay, so how can I get the probability of Z is greater than negative 1.75? Remember, we have said that, colleagues, the whole area under this bell-shaped curve is equal to 1, the whole area. But this bell-shaped curve has two sides, the left side and the right side. The left side and the right, the left side and the right side. This one, you have this line separating this one. So it shows that you have left and right. Left is equal to 0.5, right is equal to 0.5. So it means that the total area, as we had said, the total area under the curve is 1. The total area under the curve is 1. Okay, now, since the total area under the curve is 1, and you are interested in values, you are interested in probability from here to infinity, from here to the right side. Remember, this line doesn't cut the horizontal line. So it means that when you're getting the probability, you are going to get the value from here to here, from here to here, and the value from here to this line that separates, the probability, you get it from the table. So technically, you are looking for the probability of negative 1.75 is greater or equal to, okay. Now, I don't want to always do like this. Don't bring your negatives here. Always do like this. Just put 0, because you don't have time in an exam. Simplify life. Because just put here 0 is less or equal to Z, then less or equal to make this negative to be a positive, because as we read the value from the table, we read the positive ones. So in short, what you're trying to put here is you want the probability from here to this line, because you know, then you add, you know that from this line here, from this line to infinity is what? Who can tell me? From this line to infinity is what?
0.5.
0.5. So we need to go to our Z table and read this probability. We go to Z table and read this probability. What is the probability of 1.75? 1.75 is a value of Z, that we standardized. Okay, so we go to the table. I don't know whether I have the table here. Okay, I have. So let me show you. We go to the table, Z table. We go to Z table and read. Are you seeing my screen where I have tables? Are you seeing the first table with Z? Normal distribution. So we want to use this table, guys. Please master how we use this table. Your table you use must be normal distribution, because you're looking at a normal distribution. So what is the value of Z? Are you seeing this Z? What is the value of Z? You first to deal with the first two values. It is 1 point what? 1 point, the first value. The first value is
1.7.
1.7. So look for where 1.7 is. It is here. This is 1.7. Okay. The next value is what?
5.
So now this is a column. Now 5, you will get it from here, from the top values. These ones. 5 is here. So read where 1.7 meets 5, where 1.7 meets 5, that will be your probability. This one, it is what? Is it for what? It is what? It is, are you seeing that probability? It is 4,599. Let me hope the screen is visible enough. So the probability here is 0.4599. So here it is 0.4599, then plus 0.5. What do you get finally as your probability?
0.9599.
And you're done. That's all. That's all. That's always part E. That's always part A. Don't think that it takes time. No, I am just explaining. You see how many steps? How many steps do you need? You just see how many. How many? They are very, very few minutes. You need just like 4 steps and you're done with you score your marks. So that is part A. That is part. I like these questions. They don't take time. And the moment you find that you know a number about probability, you are going to pass. You're going to pass that paper. You're going to pass that paper. Okay, we are done with part A, part B, part B, part B, and the concept will always remain the same. The concept will always remain the same. So part B, part B, part B, part B we need what? Part B we need the part B of this question. Part B of this question, we are done with the probability. Part B of this question, we are doing question what? Question 2, yeah. So part B, we are told to determine the probability that its life is between 18 and what? 18 and 28. 18 and 28. So what do you do here? The probability between okay, so your probability here, here you need the probability of what? The probability that it is between what and what? Between 18. So you start with a probability of between 18 and 18 is less. I put X less what? Between less. The other figure was what? 28?
Yes.
So that is the probability that you need. 18 is not inclusive because when they say between 18 and 28, 18 and 28 is not inclusive. Eh? And when we are dealing with these things, we deal with exclusive figures. We deal with exclusive figures. We don't deal with inclusive figures. I am going to comment on how you handle inclusive figures. You first change them. From inclusive to exclusive. If you're dealing with inclusive figures, you change them from exclusive, rather from inclusive to exclusive. Okay, so here standardize because these are not inclusive figures. So just deal with the way they are. Deal with them the way they are given. Deal with them the way they are given. Okay. So when we standardize this 18, what do we get? Probability of standardize, guys. Standardize. You always need to standardize. When we standardize this 18, what do you get? It is 18 minus mean. It is basically 18 minus mean over standard deviation. Please put in the formula like here. Standardize that thing and tell me the answer. Put mean Okay, put this figure here when you standardize. Standardize 18. Now where, okay, 18. Okay, I think this one we had it already. Then less. Now where you have x put z, less. Now where you have 28 put also standardize this. So this will be equal to what? This will be equal to probability of, when you put this on calculator, we had what? Negative 1.75. It is going to be less z, less, This one on calculator, what do you get?
0.75.
Round off to only 2 decimal points. So don't give yourself hard burden. Okay, I need the probability of this. So how can I get this probability? How can I get this? How can I get this probability? It will be equal to, as I said already, you need from here to here, which we had already calculated. From there, from negative that. So I can copy this. I had somewhere this. I can copy this one. I can copy this one. For you, you write, don't copy, you write, because for you, you cannot, okay, you copy as you write. Then add from here to here. Whenever you want the region from this line to here, not to infinity, that one you get, whenever you want a probability from this line that separates to a point where it ends, that one you get from the table, Because here it's not from here to infinity. From here to infinity is 0.5, but you need from here to 0.75. So the only way you can get that probability is to use the table. So here I put 0. So I need this one to here, which is like this. Okay, so we read these ones from the table. Already we have this one. I don't need to go back again. You can just put, this was what? 0.4599. Then we add, let's now go back to the table and see what is this probability. What is the probability of 0.775? The probability of that is what? Who have seen the first table? We need 0.75. That is the first one. Then you go to column the column 5 and read the meeting point. Now here. Are you seeing how things are moving? So you need this. Copy this. Because you need where 0.5 meets column 5. So you first see where 0.5 is, so then column 5 is here. This is 27. This is 2734. 273. The way you're quiet, let me hope you have seen it. 0.2734. Are we all okay?
Yes,
Are we all?
yes, we are following.
There is following and understanding. So,
Both of them.
Excuse me, Mr.
okay.
Abel.
Yes, please.
How comes here we didn't add the 0.5, the one that goes to infinity?
Until you see you see where you want, You want this region between this and this. Are you seeing? So you want from here to here, that is the first, from here to here. This is the probability from, okay. Then add. Are you seeing what you're adding? You're adding from here to 0. What? To 0.5. What is that probability? The first one The first one, we had no ending, we had no end point. Are you saying that? Someone had asked. We had it first add from here to here. Then plus, because you don't have the end point, then you are going to simply add 0.5, because from here to infinity, it is 0.5. But here you have the end point.
Okay, thank you.
Let me hope you have understood. Here you have the end point. So you cannot stretch it to, you cannot take it as 0.5. Okay. Any other question? Any other question? Are we all okay? Are we all okay?
Yes, I'm boss.
So when you add, what do you get? When you add, what do you get?
1.2333.
Nganya, it can't be 1. How can you get a probability as 1 point something? Probability
I'm
can never be above
0.7333.
0.7 at 33, like this, 33. So that is your answer. That is your answer. And you're done with your number. You're done with your number. I want to ask you guys, if you have something like this, let me draw that, let me put here. How will you, because we are almost done with this topic, with this area about normal. I don't want to stretch a lot. Assume this is your diagram, and I don't have this. Let me delete it. Assume I don't have this. Then also assume I don't have this. Assume I want a probability of a z is less than 0.75. How do you get it? Where do you shade? Where do you shade?
The left side.
Assume after standardizing you have something like this. Where do you shade?
The left side to infinity.
You shade the left side to infinity. You shade the left side to infinity. This side, the whole of this side to infinity. You shade it to infinity. Okay, you shade it to infinity. Okay, and that one will be equal to what? Who can tell me now? It will be from here to infinity is what? 0.5.
0.5.
Then add from here to here, which is something like probability of 0, then which is something like this, the one you have here. Okay. Please note it in your book if you have that. That's what you do. I'm talking about this because just you need to know how you get this thing. Then what if you have probability of z, probability of z is greater than 0.5. on like this after standardizing. Assume you have this. What do you do? What do you do? This one will be equal to where do you shade? This one, where
Right
do you
side to
shade?
infinity.
You shed the
Mhm.
right side.
You shade the right side, eh? So you
To
shade
infinity.
this time you don't shade this side. 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 But you shade what? You shade the right side. You shade the right side. Okay, I hope some of you are copying this. You are not writing, then that is not my problem. That's not my problem. Here we shade the right side. The right side, After shading the right side, how will you state? This is where students just mess up, but otherwise other things are very easy. Now, after shading that, how are you going to get this? How are you going to get this probability? You will say what? You will say what? Someone tell me.
To be 0.5 minus probability of 0 greater or less than x greater or less than 0.75.
Yes, because you want only this region from here to infinity. From here to infinity, that's what you want. Now, to get it, you need to just know that from here to infinity is what? Is 0.5. Then I remove the unwanted region, which is from here to here. I remove the unwanted region. So this is the probability of, I remove the probability of 0, 0 probability of something like this, probability of, you put like this, which you will get it from the table. Let me hope you guys, you're picking. That's how you get it. That's this one, you get it from the what? From the table. This one. Probability, you get it from the table. So it all depends on what you have. It all depends on what you are looking for. Which side are you interested in? Don't cram. Just when you make it a table, this curve, it can help you to know. It can help you to know. Then lastly, still on this, what if I am looking for the probability of z less than negative 1.75? Because initially we had the greater, are you seeing here? Initially we had the greater, initially like here, the first one we had the greater. What if it was negative? What if it was negative? Where do you shade? What if it was negative? Where do you shade? What if it was negative? Where do you shade? Where do you shade? You still shade the right side? Where do you shade, guys? You shade? You shade the left. You shade the left because you want values that are less than, and the values that are less than, you find them this side, on the left side. On the left side. So you shade this side. You shade this side. That's where you shade. So it means that this one will be equal to what? Who can tell me? It means that this one will be equal to what? It means that this one will be equal to what? It will be equal to what? Who can tell me? You want this region that is shaded. How can you get the region that is shaded? Who? Stella. Stella, how do you get the region that is shaded? Jen, how do you get the region that is shaded? How do you get this region? Because it's online, you pretend that you're not hearing me. Other guys are hearing me.
Abel, we can hear you. I think you get 0.5 minus the probability of 1.75.
Yes, because always know that from here, from this line to infinity is 0.5. But you don't want the whole of this line. You just need this shaded region. So I get the 0.5. I remove the unwanted region, which is from here to here, which is the same as probability, like the way we had it at first. Those ones remain the same, the way we had it, like here, the way it was here. Don't put it as a negative because you don't read the negative values from the what? From the table. Just put it like this. It is a negative, yes, but you don't read the negative from the table. That's how you get. So please, if I were you, I note all these things because I have highlighted on all areas, regarding whether negative, whether positive. So that's how you will always deal with these things. That's how you will always deal with these things. Then another thing that I want to highlight on this part if you are dealing with let's say inclusive figures, how do you, if you're dealing with inclusive figures, to those who have tried to listen to the probability session, what did I say about inclusive figures? If you have those who have tried to listen the recordings, if you have let's say probability of, if you have the probability of let's say z, if you have the probability of x, let's say x is greater or equal to 10, rather less or equal to 10. If you have let's say probability of x is greater or is less or equal to 10, how do you get the figure that is exclusive? How do you get a figure that is exclusive? Then if you have, let's say, probability of x is the probability of x is greater or equal to, let's say, 40, how do you get the exclusive figures? Then if you have, let's say, probability of 10, less or equal to, okay, between 10 and 40, but the examiner say inclusive. He can add that word inclusive. So it becomes like this. It becomes like this. If 10 and 40 are inclusive, it becomes like this. So there you have to change from inclusive to exclusive. Now change to exclusive. We deal with exclusive figures. Change to exclusive. How do you change? How do you change? How do you change? If it's less or equal, what do you do? Do you add 0.5 or you raise 0.5? I remember talking about this. I don't know whether you paid attention to those who try to listen to those things. If it is less than, do you add 0.5 or you raise 0.5? If it is less, and you see it is easy to recall. If it is less, don't add. If it is less, add. Yeah. If it is less, add. It will be easy for you to recall. Just summary. Make the summary. Add 0.5 to x, to value of x, because it will be easy to recall that if I'm dealing with z, I would have actually added. Sorry, I would have actually subtracted. If it is less than, I would have actually added, but it is the opposite way. It's opposite way, that in a way, if I'm dealing with less than, less or equal to, then I add 0.5. And then if it is greater or equal to, I subtract 0.5 from the value of x. Guys, I want you master this. You master this. As you do your numbers of normal distribution, we deal with exclusive figures. We deal with exclusive figures. Now, the question is, how will you change from inclusive to exclusive? This is the concept. This is the concept. In short, we are saying, why do we add? Why do we actually add 0.5? You see, you have values of, okay, you have this, let's say this probability. If you want values from 0 to what? Values from 0 to what? Values from 0 to what? Is it to 9 or to 10?
10.
Isn't it from 0 to 10? Isn't it?
Yes.
It is to 10. It is to 10. Now, you want the exclusive value. You want the exclusive value in a way that if you add 0.5, it will help you. It will be x. It will be x less than less than what? I add what? We said you add what? 0.5. So it becomes 10.5. Do you agree that you'll find 10 here? Do you agree that you'll find 10 here from values 0 to this? Because this one is not inclusive. So if this one is not inclusive, it still helps me to capture. It still helps me to make sure that the probability I get includes also 10. That's why we are saying you add. Because if you don't add, let's say if you subtract, if you get 10 minus 0.5, technically you are getting 9.5. But remember, the probability is get the probability where 10 is included. So for you, if you subtract 0.5, you will be very wrong because you cannot get 10 in values less than this. Let me hope you have understood the reason why we add here. Let me hope you have understood the reason why we add 0.5. We add 0.5 such that at the end you can get x less than 10.5. Within 10.5, from values from 0 to, okay, any values below this, I can still find what? I can still find 10. So that's why you add. Same knowledge, same reasoning when you're dealing with greater than. Discussing disturbs students, but please know the reason why we subtract if a sign is less, and know the reason why we add. So if it's this and it is greater than, it means that I need the values from 40 to infinity. Do you agree? Do you agree? Infinity. I hope you agree. From 40, infinity. From 40 to infinity. Do you agree, guys? It is still early, guys. I want to hear from you. Because these things disturb students. I am not here for decoration. These things, you are going to meet them, and you must understand very well. So, since you want values from 40 to infinity, and you want the exclusive value, we are saying subtract. Because if you subtract, you'll get a probability of x greater than, the sign remains the same, but without what? That equal to. So it is x greater than, I subtract 0.5 from this value. I get what? 39.5. Do you agree that I will find 40 here? Because here it means that I need values that are greater than what? That are greater than this. It means that 40 will be included. For you, if you make the mistake, and subtract, if you make the mistake and add, you will be wrong. Because if you add 0.540, it will be 40, it will be 40 point what? 40.5. Yet you want the probability where 40 is inclusive. So if you make the mistake and add, it will be 40.5. So it means that already you are above 40. You cannot get a probability where 40 is included. So it means that for you, you're starting from 41 to infinity. 41 to infinity. So that is the reason why we don't add. Why we don't add if a sign is greater. We simply subtract. If a sign is less, we add as we get the exclusive values. So it means that if examiner had said that get a probability of x greater than or equal to 10, then for you change this to the probability of x less than what? We said if it is less or equal to, we add. So it will be 10.5. After doing this, go ahead and standardize. Then standardize. Then if you're looking for this one, it will be probability of x greater than, if it is greater or equal to, we subtract. So it will be 39.5. After doing that, then you go ahead and standardize. Then if it's this, what do you do? Who can tell me? What do we do? From your reasoning, what do we do? Without spoon feeding you, what do we do? If 10 is less or equal to x is what? You guys, are you with me? Temusirika nnyo. Temusirika nnyo. If 10 is less or equal to x, x is what? If 10 is greater or equal to, you want to start with x. If you rearrange, what will you have? You have something like this. If you rearrange and you want to start with x, it means that x is what? Ten is less or equal to x. Technically, it means that values of x are greater than what? Are greater than 9.5. Are greater than. So here, are greater than. If you want to rearrange, are greater than. This one is the same as this. Let me hope you agree. 10 is less than or equal to x. It means that x is greater or equal to 10. So if you have something like this is greater. This is the greater. And where you have greater, you do what? Where you have greater, you do what?
You subtract.
It will be
9.5.
x. Less what? If you have a less,
Will be 40.5.
where you have a less, now this will be 40.
40.5.
0.5.
After that, then you standardize. Then you standardize. Please, that's the best way I can really explain this. That's the best way I can explain these things. When I say then standardize, it means that you need to standardize this, put here Z, also standardize this by getting the now value of x will be this. X minus mean over standard deviation, but x will be what? Will be this. Okay, guys, I believe I have really explained very well these things. If you still have issues, if you have not understood something, please let me know. Let me know. Have this summary in your book. It will save you. It will save you. But also don't cram. Don't cram. Know the reason why we are adding 0.5. Know the reason why we are subtracting 0.5. It will help you. Okay.
So how do we tell that the question is all about the inclusive or the exclusive?
The examiner will include that word. You see here where you have, for example, here, from this question, you see here you are dealing with what? You're dealing with a life where if its lifetime is greater than what? Greater than 18. Are you saying that? But examiner can say, determine the probability that its life is greater or equal to 18 years. Are we together?
Yes.
Someone had asked. He can say, determine the probability that its life is greater or equal to 18 years. So you have the probability of x greater or equal to 18. So it means that there 18 is inclusive. You must first get the exclusive figure. Go ahead and get the exclusive figure before you standardize. Also here you can say, determine the probability that its lifetime is between 18 and 28 years. Then he puts in bracket inclusive. So if he puts the word inclusive in bracket, it means that 18 is inclusive and also 28 is inclusive. You first get the exclusive figures. Is that okay? Is that very okay?
Yes, thank you.
Okay, so let's proceed. Let's handle Roman 3. Roman 3. Determine the sample size of the panels that were tested if only two failed to exceed a lifetime of 18 years. How do you do this? If you're looking for the sample size of the panels that were tested, if only two failed, to exceed the 18, to exceed the lifetime of 18 years, you just apply your reasoning, guys. I pray that in an exam you reason. I pray, but because what we are discussing may come or they may twist. The question, it may be a question about normal distribution, but they twist the language. So you reason very well. The way you handle issues, the life challenges, or the work-related challenges. You meet a challenge and try to reason how you can overcome. You have a problem, how can you overcome this? So, like now, what are you interested in? You are looking for the sample size. That's what you're looking for. You're looking for N. You're looking for N. But they are telling you determine the sample size of the panel that were tested. If only two failed to exceed, now you have two that failed to exceed. The two panels failed to exceed a lifetime of 18 years. So what does this one mean? First of all, if you were to look for the probability, if you were to look, this is part C. If you were to look for the probability would be the X that you see the language that failed, the two failed to exceed, which inequality do you put? X is what? The lifetime is not above what? Is not above 18. The lifetime is not above 18. So it is 18. It is 18, or it is less or equal to 18. If they say failed to exceed. Do you agree that it is something like this? Failed to exceed. Because
Yes.
there it is like 18 or below. 18 or below, technically. But how can I get it? How can I get this probability? Already I know the total probability. I already have, examiner was friendly. From your part A, you already have the probability that exceeds what? That exceeds the, you have already the probability for the lifetime that exceeds 18. But here you have you want the probability of the the probability of X that is less or equal to 18. So I can reason very fast. And I know that for me to get that probability, I simply get the total probability minus the probability of X is greater than 18. I can get this direct. Because if you are given already, you are given, let's say from 19, 20, you have all those probability, 21 to infinity, That is probability of x greater than 18. You have that. But examiner is saying you look for the probability of x, x less or equal to 18. So you want to start from 18 going down. Here, 18, 18, 17, and 16, up to what? Up to 0. So can't you reason and know that now already I have this? Already I have this. How can I get this? I know that the total probability is equal to 1. If I get from 0 to infinity, the probability is equal to 1. So how can I get? I simply get 1. I simply get 1 minus 1 minus 1 minus this, minus the probability of this. I will have my probability for values which are 18 and below. So I substitute here. I substitute 1 minus, what was our probability? From part A, what was our probability here? What was our probability from A? What was our probability from A? You guys talk.
Yeah, but do we consider the one that we standardize?
And it is the same. Already this is what? This is X. Now for us, we want the probability, just the probability. All is the same. All is the same. All is the same. All is the same. This one, this
That
one
was
is
0.95. This one.
Here it is like probability of x is greater than 18. It's the same. Just that here you standardized. This one you standardized. But it is the same. It is the same. So the probability is 0. What? 9, 0 0.9. Here we remove 0 0.9 what? 0.9599. What do you get?
0.0401.
Like this, eh?
Yes.
Okay. Then I will say let my n be the sum, be the size of, be the sample size, because I need the sample size, be the sample size. Okay, already I know that those that fail to exceed the total number of the panels that fail to exceed 18 is equal to 2. They are only 2. So if I get the probability, if I get any times the probability of those that fail to exceed 18, I know that from probability from getting any time the probability that failed to exceed 18, I know that I will get 2. Because I am given the total number that failed to exceed 18 years. So what is n? N is will be any times the probability, which is 0.0401, will be equal to 2. So I need n. N will be 2 divided by 0.040. And what is that n? If you get 2 divided by this, what do you get? Tell me.
I got 49.875.
49.875. Remember, we want the number of panels, the number of solar panels. So this is approximately equal to what? This is approximately equal to 50. 50 solar panels. Those are the ones that fail to exceed the life time of 18 years. And you're done. How many marks? 3 marks. In how many minutes? 2 minutes, if you can reason. But the problem is, sometimes the students don't reason it too much. They immediately say, this one really is hard, I can't do it. Yet it is not all that very, very hard. Just if you can reason very well, you will find these papers very, 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 very easy. These probability numbers. But the moment you don't have an idea within the next 2 minutes you're reading the question, trust me, it will be hard for you to do that number. Within 2 minutes, you must be knowing how you're going to approach the question. Without that, it's very hard to pass. You'll be wasting time, and you'll be saying that time was not enough. Time was enough. Accept that you don't know, but don't complain about time. I normally say that time is always enough to score 50. Time is always enough to score the pass mark, 50. Just that we spend time doing wrong things. We spend time doing wrong things. Presenters are expected to exceed. Is that figure inclusive or exclusive?
Exclusive.
It will be probability of x greater than m. That figure is not inclusive. That figure is not inclusive. That figure is not inclusive. So you are supposed to do, you are given 1%, which is the same as, if you get 1 divided by 100, you get this. So you are supposed to look for m. You are supposed to look for m. So it means that technically you standardize m. You standardize m, and that will be what? Probability of z greater than what? Greater than m. You will be having mean from the required part, from the question. We are given mean from the question. Mean was 600 and standard deviation 80. So you get m minus 600. Then everything divided by what? 80. Okay. What do you and this one will be equal to 0.01. Okay. So you can first, this one can come at the end. First deal with this. So technically, what you are supposed to do, I know. Okay, I have no. Okay. Since I have started on it, let me proceed. So just to copy this. Let me just try to copy this, because we are dealing something like this that has only greater. That has a greater sign. I have explained these things, where to shade, where to do what. So you are supposed to do like this. I put here, I have something like this. Probability of z is greater than m minus 600. Now I don't have the value direct over 80. I don't have the value direct. So it means that where you have 0.75, I put just my m. I put my m minus 800. I put my m minus 800. Try to reason, guys. Try to reason. M minus 800, then divide by 80. Sorry, m minus 600. That is mean over 80. Because I don't have the z value direct. I don't have the z value direct. But I shade this side. I shade this side. Do you know the reason why we are shading this side? Because we are looking for probability of z greater. So we are interested in this side. So we say that the probability of this will be equal to what? Will be equal to, who can tell me what do we say when you're looking for this? You get 0 point what? 0 0.5
0.5
minus from here to here, which is the same as probability of what? Probability of 0. Probability of 0 less what? Less or equal to z, less or equal to what? Less or equal to the value here, the value of z. You don't have it. You don't have it. So I just put this. I just put this because I don't have that value. I just put this. Okay. I first deal with this. Remember, all these are equal to what? All these are equal to what? All these are equal to what? All these are equal to 0.01. Do you agree? All these are equal to 0.01. So here I say equal to 0.01. Okay, so I need this technically. So how can I get this probability of this? How can I get it? 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 It will be what? Someone tell me. This one you could take it to the right side. So it will be 0.5 minus 0.01. Do you agree on this step? Because this was a negative, I take it to the right side to become a positive. Then I bring this 0.01 to the left side. And if it crosses equal sign, it becomes a positive, rather a negative. What do you get here? What do you get?
0.49.
This will be 0.49. So once you're there, it means that the probability of your z value, the probability of this value we have here, the probability of this value we have here is what? 0.49. So this is like our z, guys. This is our z. Our z is like m minus what? Our z is like m minus 600 over 80. That is like our z. That is our z. That is like our z. We don't have it, but we know that the probability of z, the probability of z is equal to what? 0.49. Do you agree? The probability of z is equal to 0.49. Okay? This is z, because as you standardize, z is x minus mean over standard deviation. That is your z. Can you get the value of z? The value of z from the table. What is the value of z that gives us this probability? What is the value of z that gives us this probability? The probability is what? 0.49, isn't it? That is our probability of Z. So we look within the table. Don't look at this. No, this time we are not given Z. Don't say that I start from 0. What? No, here you are given the probabilities. These are probabilities. These ones within the table are probabilities. Those ones are your probabilities. So where do you find 49? You look for 49. 49 within the table. Where is your 49? Do you have 49 anywhere? Where 49 starts from? So here 49. Do you see? I think 49 starts from here. This is where 49 starts from. So which value of Z gives you this probability? Which value of Z gives you this probability? So Z, we read this, that is 2.3. First write 2.3. Then the column, where do you find that probability? It is column what? Column 3. So it means that the value of Z is 2.33. That is 2.33. Have you all seen how we get have you all observed how we get the value of Z? Have you all observed how we get the value of Z?
Yes.
So the value of Z from the table is 2.33. That is 2.33. So I have Z now. I have Z value. So since I have Z value, since I have this Z value, I can get the M I'm looking for. So from this, where there is Z put, 0.3, rather put 2.33. So what will be your M? What will be your M? Someone tell me. My M minus 600 will be equal to 2.33 times 80. My M will be equal to, remember this 80 is the denominator, is your standard deviation. So your M will be 2.33 times 80, then plus, because this one will go to the right side and becomes a plus 600. So you will be having how many miles? Tell me how many miles?
$786.4.
786.4 miles. So that's how you are supposed to tackle. This is like your X, your value of your X or the M. Is it easy? Was it very easy? So that's another way they can ask this. That's another way they can ask this. They asked this in May. They also asked this, I think it was part B, question 2. Question 2, part B. Please do part B. You have 4 marks. You are told to determine the upper quartile time. You are told to determine the upper quartile time. Where the examiner has said that the X in minutes is modeled by a normal distribution. Already, this is what I was telling you. X is normal distribution. Now you're given mean, that is 32. Then you're given standard deviation as 4. That is standard deviation. So you are supposed to look for, to determine the upper quartile time. You are supposed to determine the upper quartile time. So if X is upper quartile time, then for you, you were supposed to just say that, okay, I'm just going to give you a hint how to start, then you proceed. I'm not going to do everything. So here you are supposed to, this is question 4B. Model paper, this is model paper question 4B. So here you are supposed to just say, if let's say you can say Q. If Q is equal to upper quartile, then I can say that the probability of X upper must be greater than this, the probability. For me to get the probability of X greater than this, so here you are supposed to cook is equal to the 1 out of, okay, it is always 1 minus 3 out of upper quartile, because the upper quartile is 3 out of 4. And the total probability, remember the total probability is equal to 1. Total probability is equal to 1. So if I'm looking at total probability, then I have and I'm interested in the upper quartile. The upper quartile, remember you have upper quartile is 3 out of 4. You were told to that upper quartile. How we get those upper quartile? 3 out of 4. Now, if you have 3 out of 4 as your upper quartile, then what about the remaining balance? So my probability of upper quartile, my probability, the value that are greater than this, it will be 1 minus 3 out of 4, which is equal to a quarter, or 1 over 4. And the answer is 0. What? You get what? Is it 0.25?
Yes.
You get 0.25. So you are supposed to reason. Of course, if you can't reason it, automatically you leave that part. And do other things. So here you are supposed to, this was supposed to be your starting point. Then you look for this, Q. Using the same concept. Because if you standardize, you'll have Q minus C, mean over standard deviation. Those ones were given. So from here, your homework is from here, go and get the value of Q. So from here, follow these steps. Because you have something like this. This is M. Now where we have M, we have Q. Where we have 0.01, we have 0.25. So follow that and get the value of Q. Follow that concept and get the value of. I'm done with normal distribution.